Hello everyone, welcome back to the channel. Now in this video we are going to learn about the Stream API in Java. Okay, and it is one of the most important and powerful concept. It was introduced in Java 8 for making the use of functional programming and more easier for processing of the data. Okay, so Stream API is extremely powerful. Now we have seen that using collection framework of Java, we were able to store the data into list, set, map, wherever we wanted, okay, according to our needs. But what about processing the data? Suppose you want to transform those data into some other values. You want to apply some logic. You want to filter out certain values and only put certain values into your data structure. Okay, so to apply those operations, you need to write the logic, write the methods on your own. And when we are using data processing in the industry projects, then there lots of steps are there. Okay, multiple steps are there. So for every step, you have to write everything. Okay, and then we call the methods in the order in which we want to perform our steps, right? So that's how we were doing before Java 8. But the problem is that whenever we are defining those methods, whenever we are dealing with the data, so and we are trying to transform the data, we are trying to filter out the data, we need to ensure that data integrity is maintained. We need to ensure that we are focused more on logic rather than on concerning that how should we do it, right? So to resolve all these problems, Stream API was introduced in Java 8, and in the further Java versions it was further enhanced more with more methods, more better algorithms. Okay, so we will understand now that what is an Stream API and how it is useful for us. Now we will start with an example and we will see the use of Stream API. Okay, now the stream word itself means of the flow of data. Okay, when we say a stream of water, a stream of data, so we means the data is flowing through something, maybe through a particular pipeline or something like that, right? That is an stream. But technically in the Java, stream is an interface which defines certain methods. Okay, now before we understand the whole overview of Stream API and how we can work on it, let's go through an example. So you are using water in your house, okay, for various purposes, whether in your bathrooms, whether in your kitchen, right, or for washing your face or various other uses, right? So let's come to the diagram. So you are using water. How you use the water? Through what? You use a tap. Okay, there is a tap in your kitchen where you are through which you get the water, right? So I'll say tap in kitchen, suppose, right? So you are using tap in the kitchen to use the water whenever you require the water for your cooking the food or washing the utensils, right? Now the question is how you are getting the water. Water is coming from somewhere. So most commonly it may be that there is some water tank at the terrace of your house from where the water is coming, right? So let's indicate a water tank. Okay, so suppose this is a water tank. Now from here the water is coming to the tap, right? Perfectly. But is it actually coming directly from water tank to the tap? No. How it can come? There is no way for this water to come to this tap. So what you have made is a pipeline. Okay, you have a pipe collection. So there is a pipe connection that you have made. So let's make this pipe connection here, and I will say this is a pipe connection. Okay, so there is some kind of pipe which you have built which connects your water tank to the tap. But even after connecting this pipe from tank to tap, are you able to really get the water? Think about it. The answer is no. Why? The pipe is set up, the water is there in the water tank, of course, but you still not getting water from the tap. Why? You will get the water in the tap only when you turn on the tap. All right. So you need to turn on the tap to let the water flow from the pipe, and then you get the water, right? So this is the whole process that generally we see, and it's very common, right? Now in terms of Stream API, something similar works here also. So this water tank, you can consider as your data storage, okay, or your collection. It may be a list, set, map, anything, okay. So this is a collection, list, set, or map which contains the data. So it is a data tank or a data source, okay. What is this pipe connection? So these pipe connections are some of the methods which are defined by the Stream API, which is used for transformation of data. But these methods are lazy methods. Now what I mean by lazy methods, now as I told you, you directly don't get water even though the pipe is connected to the tank. Pipe is connected between tank and tap. You need to turn on the tank, you need to turn on the tap if you want to get the water from the tank, right? So you need to do something in the stream to make the data flow. So what is that? So here the tap means, in terms of Stream API, it means there are some kind of operation that you have to perform, and these operations are known as terminal operations. I will say terminal operation, okay. So using these terminal operation, only when these terminal operations are called in the stream, then the data flow through it. The methods that we have defined to process the data gets called, and it applies to those data, and then you get the ultimate result, okay. So I hope you have understood an overview of how things work. Now what is the benefit of using this? Now if you don't put a pipe, if you don't put anything, right, then what you have to do is you have to take a bucket, okay, and then go to the terrace, take the water from the tank, then come, then again go with the bucket, take the water and come. It's very tedious, you'll get tired, and it's, I would say, not really making a sense, right? It would not make a sense. That's why we are using the pipe connection here for the water. Now how pipe connection is working, how water is flowing through the pipe, are you actually concerned about it? No, you are not really concerned that what's happening there. You just know that, okay, there is a water, here is a pipe, I turn on the tap, I should get the water, my job get done, right? You want your ultimate result, and your ultimate result is water. So similarly, you have a data in your list, your set, your map, you want to achieve something with it. So suppose you have a list of integers, you want to find the sum of all the integers in the list. So what is your goal? Your goal is to get the sum of all integers in a list. You are not concerned how it is being got, right? You only want that result. So that is how Stream API will provide you the methods, or you can say the Stream API will provide you with the methods which can help you achieve this. How it will do it, that should not be the concern, okay. It is taken care of internally by the Stream API, okay. Now second thing that we discussed was, and which is most important, is data integrity. Now when you are manually doing anything, there is a chance of data leakage, there's a chance that the data gets mutated in a way that you don't want. So in case of this water tank example, if you are using the bucket, it may be the case that while you are having the water in your bucket, some water may spill out, okay, so that is a loss of water. So similarly, if you are manually writing your methods, there may be a case, the first of all, the algorithm that you are using may be inefficient. There can be a chance of data loss due to mutability, okay, or maybe due to the design of the algorithm. And it happens mostly when you are working in a multi-threaded environment, or doing some kind of parallel computation, right? So to avoid all this complexity, the Stream API handles all this internally behind the scenes. you don't have to worry as a Java developer. You just have to focus on your logic, right? So we will see now actually about the Stream API, and we will discuss the examples how this is done. Okay, so let's see some small theoretical thing about it. So Stream is basically an object on which we can define operations. Defining operations means how to transform the data, how to filter out the data, or how to perform the, how to aggregate the data. Okay, so all these things are defining the operations. We will see everything by example. Okay, no worries. It does not hold the data. It is not a data structure. So Stream here basically is a pipeline. Okay, you are making the water flow through the pipe, but the water is not stored in the pipe, right? It is, the pipe is basically a medium for water to go from water tank to tap. So in the same way, Stream are the way for the data source of, or are the way, are the medium. So in the same way, Stream is a medium through which the data get processed. It is not used for as a data storage. Okay, it is useful for processing data, processing in bulk. Okay, so as many as data you can do it. Okay, and it will do with the same efficiency, right? Streams don't change the order of elements it gets from the data source. Okay, so immutability is the very much taken care of. So you don't have to worry that, okay, if anything happens, if my data changes. So data integrity is basically taken care of. Once a stream is consumed, it can't be reused. So if you are using the stream once, and the data that once flows through one stream, it cannot be again flow through it. You cannot use the same stream again. You need to create another stream object, and then you need to process the data again. Okay, so this is how things are getting done. Now in stream there are two types of operations that we do, as we have seen here, on which we define operations. So what kind of operations we define? So two operations. One is intermediate operation, which is a lazy type, and it returns another stream. Why it returns another stream? Because as I told, once a stream is consumed, it can't be reused. So one operation consumes a stream, get the stream of data, do something, so it has to return another stream, because the same stream cannot be used for the second operation, right? So that's why. And terminal operation is an eager operation, which means it returns some useful result. So the ultimate result which we actually want is returned by terminal operation. The most important thing is intermediate operation only runs when terminal operation is present in the chain. So the thing is here, the water will only flow from this pipe and come to a, you can use in the tap when you turn on the tap, right? Unless you don't turn on the tap, the water will not. So in the same way, the stream or the method that you use from the stream will not work. The intermediate methods will not process the data until and unless you don't have a terminal operation. So now let's see some example of it. Now let's first define a data source. So let's define a list of integer. Okay, integers, new array list, or maybe just I define list of 1 2 3 4 5 6 7 8 9 and 10. So this is the list that I have defined. Now I want this list to process. I want to, maybe suppose I want to filter out all the even numbers and only want the list of odd numbers. Okay, so what I can do is I can simply write integers. Now as I said, to process those integers using Stream API, you need to first set up the pipeline, or you can say set up the stream. So how to convert this list into a stream? There's a method known as stream. Then what we have to do is we have to filter the numbers out. Okay, we have to remove the, we have to check that if the number is even or odd. So we apply the filter. There's a method known as filter which takes a predicate interface type object. So what predicate does is it takes a value and it returns a boolean. Okay, so we are taking one value e, and we will apply a condition. We will apply a condition that only allow odd numbers. Okay, so if the number is divisible by 2, only then allow the numbers to process further. Then we need the list of even numbers, so we will say to list. Now we can convert to array also, but since our condition is list, so we will do this, and then we will introduce a new variable. We will say even numbers. Okay, and we will simply print the even numbers. Okay, now important thing to see here is this integers dot stream converts into a stream object. Okay, this stream object is then consumed by this filter method, and this filter method is known as the higher order functions. Okay, because this function is able to take another function, right? Lambda expression is of course a anonymous function, right? So that's why a function taking argument as another function is called as higher order functions, right? We have already discussed in our Java course playlist. You can go to the playlist section and check out the video there. I will put that link in the I button also. And then we are calling toList. Now this toList isn't the terminal operation, so only after we call this, the thing is now done. If we run the method, we are getting 2, 4, 6, 8, 10, right? So this means the our stream is working. Now let's make it more complex. Okay, so we have integers of all. Now suppose we want to transform these numbers. Okay, so how we want to transform these numbers is for 1 we want 1 into 1, for 2 we want 2 into 2, something like this, the square of their numbers, and then we want to add them. Okay, so what we will do is integers dot, first we convert to stream. Now for transformation there is a higher order function known as map, so we can use this map. Now this map function requires a function interface. It's not a functional interface. I'm saying a function, the name of the interface is function. Okay, it is a functional interface, but don't get confused. That's what I mean. So what this function interface takes, it takes one argument and then it returns this argument. Okay, so let's extend this. So let's implement it. It's taking an argument. We want this to return a square of the numbers. Okay, so for every element that we get, we are doing the square of it. Then we want to add all those numbers. Now to add the numbers, since this is an integer, so to add the number we have something known as reduce. So reduce basically means that the reduce function's main purpose is to reduce all the values into a single value. Okay, so it will reduce all these values into a single value through some logic. So the logic is we need to add all those things, whatever we are getting. So there is a method in the integer class known as integer sum, so we can reduce this. Okay, now I write it. Okay, it takes a optional. Okay, no problem. So we'll say optional sum, then we will just say optional sum dot or else get. We have discussed about the optional in the last video, so we will use the or else get because it is most efficient. It only computes the default value when there is when in the optional there is no value. Okay, so we will say we need 0. In case there are nothing, it means sum is 0, right? This is how we are doing it. Now if we apply the operation, we get 385. Now to verify this whether it is doing the right operation or not, we can use a conventional way also. So we can use a for loop. So for integer I in integers, what we can say is we define a sum. Let's define a sum as 0 initially. So first we want to square the numbers, so we will say int square equal to I into I, and then sum plus equal to square. Okay, this is a simple logic that if we have to do via for loop, we have to do like this, right? And then we will simply print the sum. So in case there are no values, we will get 0. So this is what we wrote here, the default value. If there is the list is not empty, then we will get the actual sum. So it will take each value from the list, it will calculate it square, and then we will calculate the sum of all squares. So let's again run. So you can see, even through conventional way, we are getting the same, right? So this is how we are using the Stream API to achieve this thing. Now don't worry, this is not the first and the last video on Stream API. We will be discussing in advance or in detail about each and everything. This was just an introduction to it, and these were two simple examples that we have done. There are a lot of complex examples and a lot of questions that are useful from the interview perspective also. So I will be discussing all those things, from simple questions to some of the advanced questions related to Stream API. Okay, and all the methods, important methods, we will discuss. We will discuss about map, filter, reduce, flat map, how to set up multiple methods and process the data. Okay, so we will see all of them in the upcoming videos, right? So that's all for this video. I'll hope you have understood and get an idea of Stream API. So I'll see you in the next one. Till then, bye bye.